Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. First, as we all know, we can see the world through the animal's eyes, or at least not yet. But don't worry, technology is here to help us. Using all the knowledge that we've got, all the lenses, combination of measurements, the resolution, the reflection, the technology, the computed images, and etc., they all have helped us create an almost perfect picture of how can animals view the world. And here I am specifically talking about the colors. By studying the physics of the eyes, zoologists now know that each type of animal has different number and type of cone cells, or something that we call photoreceptors. For example, birds have 4 types of cone cells. Unlike human, we have only 3 of them. So birds can view the world in a completely different perspective, something that we call ultraviolet light. And here you can see the difference between us and the birds. And now for our loyal friends, dogs. Besides being cute and having a great sense of smell, something that you might not know about dogs, that they can't see clearly. Dogs have only 2 types of cone cells, yellow and blue. They don't have a wide palette of colors to choose from, so they are considered as colorblind. Now I'd like to move on to one of the most interesting animals to talk about, which are bees. Even though bees can't see the color red itself, but they can view other reddish wavelengths such as orange or yellow. The colors bee sees are blue, green, violet, and ultraviolet. They don't only see the world in different colors, they see it also in different patterns. What I mean that they view the center of the flower in a different color, something to facilitate the process of pollination and absorbing the nectar. Now for the great finale, cats. Cats have many roles than humans, which enhances their ability to see in the dim light. But our retinas have more cones. This gives us a fantastic daylight vision, vibrant in colors, and excellent detail resolution. But cats have a visual field that expands up to 200 degrees. Unfortunately, us humans can only see up to 180 degrees. Cats, are like dogs and many other animals, have a layer that is called a tapetum lucidum, which is a reflective layer behind the retina. While this appears to improve the ability to see in the darkness, it also reduces their ability to see in the daylight. So it's a 50-50, it's a win-lose situation. You either win this, you win that. I guess there is no win in the animal world. So Oscar Oasis is a very popular TV show. Oscar is a lizard, and he is going to carry the next topic that I'm going to talk about, which are how does color affect animals? Well, a scientist named Putman tested 4 t-shirt colors, green, blue, red, and gray, by measuring how much she can get close to them before they flee away, something that we call escape behavior. And just guess which color wins. It's blue. Putman says, we found that lizards were not as afraid of blue as other colors. Lizards would flee an average of 100 centimeters away when Putman approached them wearing blue. However, when she wore a red t-shirt, they fled about 200 centimeters away. Now for the last thing regarding the relationship between animals in colors is how they change theirs. I would like to play this short video for more understanding, and then I will pass this presentation to the next presenter, Adam.
Chameleons' color-changing ways are well known. but precisely how they do it has remained a mystery. They're far from the only animals with the skill, deployed for camouflage in reaction to stress, to warn predators, woo partners, even to regulate temperature. The golden tortoise beetle does its color changing while mating. But how do animals change color? In many cases, the process starts in the eye, where the colors of the environment, a rival, or a mate are acquired. But how does the resulting signal in the brain lead to a change in hue? The answer lies in cells called chromatophores. Some contain sacs of various pigments. In animals such as the octopus, squid, or cuttlefish, colors change when a complex network of muscles adjusts the sizes and positions of different sacs within the skin. Other creatures use optical trickery in related cells called iridophores. In damselfish, light waves bounce between thin plates within these cells. The color reflected depends on the spacing of the plates. The fish can precisely shift that separation across millions of cells by just billionths of a meter in under a second. Chameleons, scientists have just worked out, use a bit of nanotechnology. They have 2 layers of iridophores, each containing regularly spaced crystals of the chemical guanine. When combative males strut their colorful stuff, they're changing the spacing within each crystal lattice, creating what are called band gaps that permit or preclude the passage of certain colors. Humans, however, experience a rather simpler color change.
Don't blush. It's nothing to be ashamed of.
Blushing is just a rush of blood to the face, parts of which have larger blood vessels closer to the skin's surface. Although it's easy to induce the effect, the biological purpose of blushing is still a matter of debate.